Okay, few things I wanted to tell about our lab and assignments and other things. So when see in this course, basically lab and assignments are kind of same thing. There is not going to be a separate lab exercise as such. Okay. Um, so what you are supposed to do during lab is to actually do the pending assignments or spend time, like I said, learning from online resources further into the subject because we are not going to cover everything. Okay. And the idea of lab generally is for every course is that professor and TA will be there to help you uh, about any doubts or any exercises. But unfortunately, in this case, like we discussed, our TAs wouldn't be much of a help because they might also not be aware of the cloud computing concepts, right? So, but good thing is that everything that we talk about is technically available online, and we can, you know, find the resources and proceed further. So this course, like I discussed, is more about how to do things than why of the things. Many things in our discussions will be why such thing is there. But when you are doing a lab exercise or an assignment, most of the time it will be how to do some stuff, right? So that how to do should be easily available on the internet also. So we need to be a little smart about it and learn through that route to address our handicap of uh, like not much help from humans being available, right? You can feel free to ask questions in the group in our Google classroom, and I will be able to you know address that. um, from tomorrow onwards, I hope I will be able to join the lab for some time at least, or you can ping me and I should be available to answer your questions if any. But there isn't. I am not planning any separate lab exercises and assignments differently. They are going to be same thing. Okay, so I hope that makes things a little bit more clear. Anybody has any other questions on this lab and assignment? Submission part was like I discussed. You need to submit some proof that you have done the tutorial or the online exercise, um, because otherwise, how would we know that the lab was complete or not, isn't it? So do you do that like um, some way of showing that you logged in and like take a screenshot last page when they say your tutorial is complete or last step and you have your login on the top right, so you can take a screenshot of that and submit, or any output that comes uh, of doing some exercise that you can submit. There's some proof so that there is a tangible evidence that you have done it, then that should be sufficient. In such cases where there is no submission possible of the thing to be done, like if there is some exercise or all, so that is fine. Okay, so these are few things that came up. One more thing about the credit card and all. Again, um, I think all cloud service providers do provide student accounts, but it could be true that for them also there is a requirement of credit card. Um, Unfortunately, there is no common credit card that can be used, obviously, right? So you'll have to arrange one yourself. I I uh, I have not been able to find out a solution to this problem of how how credit card can be passed. I mean, work around through this. There is no common account that you can use, like provided by DICT or anything, because there is um, money involved, right? So if DICT procures something and every one of 200 people starts using it, let's say 200 VMs, it will be costing too much. So nobody is helping me over there to get something. So you will need to um, have some such information from your parents card or friends card or something. But I think most clouds give student credits. Like Azure, I know gives $100 student credits, so you need to use it judicially. Don't just create large VMs and just let it run without having to use it. Then your card will the this thing will expire the credit, and then it won't have anything when you want to really use it. So that is the. I mean, there is no alternative to credit card. I think even debit card doesn't work. It has to be credit card, I think. So that is not very helpful. But somewhere or other, these days credit cards are available. You can um, take one yourself or ask your near and dear ones, your parents or some elder sister, brother, to help you out in that. Yeah, so these were the few things that I wanted to tell you. Any other doubts or anything else related to course if you want to talk before we uh, move further with our content of the course? Anything else?
Sir,
Yes,
do we have to perform both AWS and Azure assignment or any one of them?
any one of them.
Okay, so in case
No, no, sorry. No, no. For this assignment, which I asked you to do both, it is because I want you to start get familiar with both environments. Okay. But if it is a, let's say, credit card in one is working and the other one is not working, or you don't, one is working without credit card and one is requiring credit card, then you just do one and mention in the submission that the other needs a credit card, which I have not been able to arrange yet.
Excuse me, sir.
Yes.
Sir, in Azure, we have tried it's working without credit card. We have
Great.
created
Then,
account in Azure without credit card details. So can we submit that Azure part only?
yeah, go ahead. That's fine.
Okay, thank you.
also in case Azure, we are getting a certificate of completing the tutorial. So if we submit that certificate only, that will do, right?
Mm, yeah, that will also do. It's fine.
Okay.
And from certificate, there is another point. Actually, these cloud service providers, right? They offer certifications in their cloud competency. So you can take advantage of this course and try to gain some certification, one or two certifications. But it I think costs some money, but I think it's worth spending it because then it's a proven fact that you have the skill and it is valuable. Um, but ultimate knowledge will definitely be your own, and it will come through when you talk or do stuff in your work. But certifications do help. So try if you can, like developer level certificate and beginner level certificate. And as you progress in your certifications, like starting with the Azure fundamentals, for example, then you can create your LinkedIn profile and start putting your certificate achievements over there. Anything that you learn or do which you think people should know, just mention it in your LinkedIn account because that is a uh, professional network, not social network as such, like at personal level. I think all of you would know, and you should mention it there. Don't go by my example. I am there on LinkedIn, but I don't post much. But I think it is good to let everybody know. My time is almost gone. Your time is there. It is starting, so you should make use of the social network. Because I see a lot of people doing that. I think it's not early to, I mean, never late to start. And you guys are just entering in your career ways. So that is another thing that you can do. Okay. Anything else? All right. So let's start with from where we left. So we were discussing about data center technology, and in Azure, we discussed that we have something called availability set, right? And then we discussed the concept of um, fault domains and update domains, things like that. So why they are important? So because when we are using Azure or cloud service provider as infrastructure as a service, when we are using their virtual machines, then this concept of which fault domain, which update domain, and which availability set they are there, it it could make a difference. Meaning, you should not be ignorant about it. So how is that going to, how this knowledge or how putting the right machines in right availability set is going to help you? That I we will talk about in and through an example or some exercise. I just wanted my digital pen to start working so that I can draw, but unfortunately it's not working since morning. Oh god, come on. Anyways, um, so exercise could be like this: that for a web application, following are the resources that we are going to create in Azure. Okay, two servers, S1 and S2, that is for serving the HTTP requests, two database servers, DB1 and DB2, and maybe two business logic servers for processing or backend or business jobs that for the service. How will you distribute these machines in availability sets, fault and upgrade domains to make a system resilient to failure? Right. So in a typical environment, just give me one more minute. I can try with a different. Sorry, it's not working today. Very sad. We'll have to do with some hand drawing or some scale drawing. So let's draw. Um, as you would know, so what we have in our typical systems is we have two sides, right? One is on the left side here. This is the client side, right? And server side. And through internet, we get the requests from client side to server side. Client side means our desktop browsers, our mobile phones, apps, and browsers, and other anything calling the API. So on the server side, it is important. And when we are saying server, this is going to be more like cloud on the cloud, right? So on the cloud, we have this whole server setup. And what it does basically for client, what client side sees, meaning the application code, what the application is running in the mobile device. So let's say if this is mobile device, it will uh, you know run the code. So what it is looking or getting it from server is basically it is sending some requests to the server, and it is getting some responses to those requests. So these are generally what do you call them, REST API calls, REST. So how it is happening? It is basically this guy, uh, the server is exposing some API from its the setup that we have talked about. Okay, so it exposes this API. So like this, and this API, it is like URL, UML way to show an interface. So API is basically a set of URLs like HTTP, um, server API example slash uh, login, right? And then it might require some. So when the this is the API call and API interface, and when this call is getting made from the mobile side inside of the code, it will have something like, let's say, username equals to Lovemeet Singh and some other password and stuff, right? So like that, the REST API will be called, and the code that is going to receive this. So this is the what you can say handler code, right, or controller in our MVC paradigm, a model view controller thing. So this code gets triggered automatically by the underlying web server. Okay. The point is that the code is written by us, that handler code, but it is deployed on a web server, right? Because web server is the one who is knowing or who comes to know that somebody called the REST API, and this particular REST API, server API login, and then which is the server side code that should be called by the web server. So the web server, underlying web server like IIS, Information Internet Information Server, or Apache, those are the software which you install on your VM or machine, and then they start listening onto HTTP port, which is 80. Okay, and then when you deploy an application on those servers, that will then those requests that are coming to that particular port, they will, I mean, it will expose 80, and then the application will be having some dedicated port on the server, and the web server will receive the content and check the URL and send the call to that particular handler or controller. Okay, that is how our application from mobile side reaches to our server side. And once the so this code, once the control comes to us, so here we have the here we have the code, and then this could basically execute the code and send the request response back. So there will be a response back from the API called back to the client, which the client might be waiting for synchronous API, or it might be doing other stuff and through for the asynchronous call. So our handler code could execute the request, but generally for large applications we have different setup. We have like a layered architecture, right? Here, let's say this is our business logic servers, and then there will be at the back database servers, right, which will be hosting the databases like SQL Server or something, right, database layer. Now there might be inside of these there will be machines like we are discussing in our example, that there are two machines for DB1 and D1 and D2. Two machines are there in this configuration as SQL Server, right? So they have a synchronized database, right? There you can think of logically, even though the application, the database will be deployed on separately on these two machines, but you can think of that for this example that they are basically talking to the same database. Okay, but physically it is going to be separate database but synchronized, but logically you can think of it as a same database, right? So no matter what it means is, no matter whether a request through the controller to the service layer, uh, through service layer or business logic to this database, whether the request comes to this server or this database machine or this, it is basically going to get the information from the common database only, right? So that is what the logical thinking is. It does not matter to which database server the response comes. Similarly, um, there are cases where you will have only one machine in to handle the business logic. Many times for many projects, there is not separate business logic layer at all. There is just handler logic which directly talks to this handler code which directly talks to the database server. So that is also common, but for large applications, recommended thing is you should have a dedicated processes for business logic. And another case for separate business logic machines is that there might be background tasks that run. So what could handler code do? It will simply what do you say, put a message in a queue, okay, saying that this task is to be done, and then returns the request back to the mobile application or client side saying that I am doing this request, right? I am processing it. Then the there will be a trigger that will happen, and business logic resource will get pick up the request from the queue and execute it. Like that could also be a separate business logic thing. Okay, so that is the idea. That is how a three n-tier architecture, right? Service layer, business logic, and database layer. Now, if this is to be done in in Azure, how would you distribute? So we have the question that, or exercise that, we have two machines for each of the layer, right? The two machines. So how would we? So we are going to create those VMs, and if we are going to create those VMs, then they will go in some upgrade and fault domains, right? And they will also go into availability sets. So what kind of distribution we should do so that it is working fine? It will work fine, or it will be better in terms of design. Okay, so that is the question. Now, obviously, if you have only one machine in each layer for each layer, then it doesn't matter, right? Then you put all of those three machines in one availability set, then it is job done, because you have only one machine for each role, right? Now, but if you have two machines for each role, like our exercise says, we have got two machines, um, S1 and S2, for serving the HTTP requests, right? Two database and DB1 and DB2 for database management, and B1, B2 for processing the backend or business jobs for the service. So we have two machines for each kind of work. So that means we'll have to create six machines, right? Now, this is our logical diagram, but let's say we are creating the VMs, right? So we have got one VM, two, three, four, five, six. Six VMs we created, right? Now we also, let's say, created three availability sets. So this is AV1, availability set 1, and then we will create two more of like this, right? So let us put them here. How would I? Just a second. Let me think. So one more. We have these three availability sets. So this is AV1 availability set. This is AV2, and this is AV3. So why I created a three availability set? Why not two? Because I have three different roles. Okay, and at least one availability set is effective if there are two machines in that. Where is that? Um, just a second. Did I discuss about it right? If not, basically the SLA, yeah, here it is. So the SLA holds if there are two or more VMs in one availability set, right? So two or more, minimum two are required. So why I am creating three availability sets? Because creating six machines, I have to, because that is what my exercise says, that we have six servers. But why three availability sets? Why not two? Why not one? Right? Why this decision to have three availability sets? We can have one availability set, like I said, and put all six machines in that availability set, right? So they will be up and running, but there is a problem. What is the problem? In one availability set, we uh, the machines that are going to be up all the time, that is the SLA of 99.95%, will be applicable to one availability set, right? So this VM1, VM2, and all the way, all combined together, they will be up 99.95%. So it means Azure has more flexibility, meaning for them it is easy, because if you have six machines and one availability set is kind of a one so then you are having it ease, right? So you have six options, you can restart one machine another and all, right? So we don't want Azure to take advantage of that. So we want to put, let's say, two machines in each availability set, okay, so that our SLA holds. So Azure will make all three of the availability sets will have 99.9%, 95% availability or uptime. Now we decided two VMs in each availability set, the minimum one. Okay. Now we want to decide the roles. So this is our, let's say, S1. This is S2. Okay. Okay. Let us start. Let us do one thing. Let us start with the next set. One availability set, all six machines in one availability set. We discuss that. Let's see what if we put two availability sets in three each, right? One and then second one. So these machines are split into two availability sets. So what is wrong with this approach, right? So I would say, for, let's say, I have server 1, S1, which is serving the requests, right? Business 1 logic machine, which is taking care of the business logic, DB1, the database machine, right? So I distributed like this: server 2, business 2, and DB2, right? So I have this distribution. This will also work, because what I will do is, there are two availability sets. This is AV1 and this is AV2. Two availability sets are there, right? And Now, if this machine goes down, right? This one in the, why it is selecting all of it. So if this S1 machine goes down, I will just speak that so that I don't have to struggle with selecting all. So if S1 machine goes down, right, S2 machine is up because it is in a different availability set. If B1 machine goes down, B2 machine might be up because it's in a different availability set. So what is the problem in this case, right? It might not be apparent, but if you remember, availability set means the machines in this availability set will not go down at the same time, right? So um, let us take an example. Let us, okay, let me write here. So one scenario is S1 goes down, okay, and B1, then D1. I will write D1 instead of DB1, okay, just to make it linear look. And then S2 and B2 and B2. This is our setup, right? In availability set 1, so AB1 and AB2 are completely independent from each other, right? And let's say S1 is down, okay? Then at the same time, our AV2 is available. The requests that are coming to S1 and S2, remember, the requests are coming in this format. S1 is here, S2 is here. Like I discussed for the DB part, one request could come to any of the servers. Okay, they can be, any of the two can receive the request. So if S1 is down, my S1, S2 will be up, right? So my machine, my service will not go down. There will be still a machine available to pick up the request and execute them. So what is the problem in this setup then? Is there any problem or this will be okay? Similarly, my business logic, business server is up, my B2 could be down, but they could be, still be able to take up the request because B1 and B2 both are taking up requests from either S1 and S2. Right? So this block is taking requests from this block. So any of the two can be used, right? So it will still work. And let's say these D1 and D2 are both up. In this situation also, my service will work fine because at one point in time, my server S1 or S2 or business logic or DB2, all the machines will be up. So the requirement is for the goal. The goal is basically maximum uptime. How can my service remain all the way, all up, all the time up, so that my clients do not face any requests, any what do you say, um, denial of requests. They always get that response, right? So that is my maximum uptime. So for that, what is my request? What is the requirement? Requirement is that server side, business logic, and database all should be up. At least one should be up. One should be up. Meaning, out of server, business, and database logic machines, at least one should be all the time up. Because if that is so, in this case, for example, my S1 is down, but my S2 is up, right? My B1 is, B2 is down, but my B1 is up. So at one point in time, if every category is up, server, business, database, then though the service request will continue to be handled, right? But if both server S1 and S2 can be down, then becomes a problem. Even though if this is down, okay, and B2 becomes up again, even though my four both business logic and database machines are up and running, all four. None of the server machines are up. The service request machines are up. So how will they receive the request, right? So these two machines go down. This one, these two. Then how will the rest of the functions or rest of the system function? Even though these four machines all are up, right? It won't work. The request will not be received by the server because the machines which are receiving the REST API call from the web server installed on these servers is not up and running, right? So that is the requirement. Now, in this scenario, with two availability sets and three machines of different roles in each availability set, is there a possibility of uh, both same role machines going down? Okay, that is the point we need to understand and discuss. That we make sure we understand it, right? Because it seems to be working fine. This setup looks like it will work fine, right? But remember, this availability set and the second availability set are completely independent from each other. The SLA will be holding for AV1 separately and AV2 separately. So they are independent of each other. It means these two do not coordinate which machine will go down in which availability set. Like AV1 does not ask, oh, is your S2 down? Okay, so I will not make my S2 down because your S2 is down. No, nothing like that happens, right? There is nothing in a setup that takes care of such things. But within itself, within availability set 2, it will ask, oh, my S2 is down, then I will keep at least two of them up or one of them up, right? So because as a unit of availability, this AV2 will make sure at least one machine is always up and running. Because as a unit of availability, you are making the resource or the compute resource available. The availability set is making sure that compute resource is available. So it, for example, it will not um, update all of them together, right? So it will distribute the machines into different fault domains, for example, right? That is what Azure will automatically do when you create an availability set and add the machines into them. It will be distributed according to in different fault domains and different upgrade domains. That is how availability set can execute, right? If you don't make sure, if you are creating availability set in Azure, it's a logical grouping, and then adding machines to it, then Azure will take care that all the machines that you're adding in an availability set are in different fault domains, for example, right? Or different upgrade domains, because that is the execution, or that is how Azure is going to ensure that availability set has all the machines up and running. Not all of them are down because power got cut. Not all of them are down because restarted. They were restarted because of the update pending, right? That is how Azure will make sure by distributing these S1, B2, and S2, B2, and D2 in different fault and update domains. But logically, for us, for the users of Azure, what it means is that AV2 will not make all three machines go down. That is the promise that it is doing, right? But there is no coordination between two different availability sets. So let's say in one availability set, our S2, S1 is going to go down, right? Because there is no coordination between availability sets, S2 could also be down, right? Because it is independent of S1, it is independent of AV1. S2 is inside second availability set. So, and it might happen that AV2 decides that S2 should be down. At the same time, AV1 decides that S1 could be down, right? And this is true for anything else also. AV1 decides that B1 will be down. AV2 also decides that B1, B2 will be down. Because still other two machines are up and running within themselves. Availability sets are fine because they are making the machines available. The other two machines are available. So even in this setup where we have two availability sets and three machines of different roles in each availability set, then also there is a possibility of our service going down, right? Because this requirement is not getting met. If S1 and S2 both are down without the fault of Azure or availability set, because they are working fine individually. How did we set up the overall? Because this is our decision, right? To put S1 in one and S2 in other. This is our decision, right? Because we assign, when we create the machines, we assign the availability set to each machine. So this is our decision, not Azure's decision. And this requirement does not hold because by chance S1 and S2 both can be down, though it will be lesser as compared to single machine, right? Each machine having single thing, or all six machines in single availability set. It will be lesser than that, but it will still be there. It could still be there. And if any of the three can be down, any of the three, meaning same role machines, a pair of same role machines are down, then our service gets disrupted because it won't work without business logic. It won't work without D and S also, right? Therefore, putting three machines of different roles in same availability set and having two availability sets is not the solution. It is not optimal distribution. Okay. Now let's discuss the idea of uh, two two machines. Okay, let me see if I can select this. Control C, Control V. Okay, one machine here. So let me make it a little smaller. Control C, Control V. Two machines. Sorry, one second. Two machines in one availability set. Third. And two machines in three availability sets. Okay. Now, let us say I put it like this. One way is that I put S1 here, S2 here, maybe B1 here, B2 here, and let's say D1 here and D2 here. This could be another way, right? Now, does this solve our problem? No, because problem remains same. We have two availability sets, and at the same time, S1 could be down, S2 could be down, right? Same problem that we discussed. So this also is not going to work even if you put three availability sets. So what is the solution? So the solution is put same role machines in single availability set. That is the solution. B1, B2. D1, B2. If we do this, now let us see what happens. They are independent availability sets, right? So availability set will ensure, V1 will ensure that one of the two machines will always be up. Otherwise, it is not going to be able to meet the SLA, right? So it will ensure that S1 and S2 are in different fault domains, in different upgrade domains, isn't it? That's what the job of availability set is. So at the same time, or at one time, only S1 or S2 can be down, right? So that means if S1 is down, then S2 has to be up, isn't it? Similarly, AV2, it has no link with AV1, so it will ensure only within itself, either B1 is up, down, or B2 is down. None of time it will be both, right? So B2, if B2 is down, then B1 has to be up. That is the reason why availability sets exist, right? Similarly, if D1 is down, D2 has to be up, right? So let's say D2 is down. If D2 is down, D1 has to be up, right? So now if we see, is this requirement met at one point in time, one server, one business, one database at least should be up. So one server, S2 up, one business logic, B1 up, one database, D1 up, right? So if S2 goes down, S1 will be up because availability set will ensure that. Now, still three machines are down, three machines are up, but we still have the service running. Okay, so the key point is add same role machines in one availability set. Okay, add same role machines in one availability set, then it will be most optimal solution. Is that clear to everybody? Any doubts? Same role machines in one availability set. Role S1, S2, same role machines, servers, or service request receiving servers. B1, B2, same role machines, business logic machines. D1, D2, same role machines handling databases, right? So AV1 will ensure either of the two is up, AV2 will ensure either of the B1, B2 is up, and AV3 will ensure either of the D1, D2 is up, right? So effectively, this whole setup is our server, and this will ensure that our service is up and running 99.95% of the time. Okay, so it is going to hold the SLA 99.95% of the time. So is there a downtime still? Is there a downtime still possible? Can anybody tell that? Anyone? Is it possible to have a downtime? Because now either of the two will be up and running. So at one point in time, all three roles will be up and running. And the requirement is that we should have at least one up and running. So it is one row, one machine, one of each role should be up and running. So it is getting met. So is there a possibility of downtime still? Anyone? Speak up, folks.
Power cut in one availability set.
Yes, but availability set is a logical grouping, right? So there is no physical availability set in the data center. So S1 will have a separate power resource, S2 and S1 will have separate power resources. That is what the fault domain. Okay, so you should speak in cloud terms. Like when you said power cut, you should say fault domain problem in S1 and S2, right? But fault domain problem could be power cut, could be network cable, could be other physical thing, right? Some screw fell and the hard disk got detached and crashed, something like that, right? Anything related to hardware, but mostly power supply and network failure. So fault domain will be separate. So if S1 goes down because of power failure, S2 will have a separate power source. So it is not going to be go down. So how is this perfect? Is this like 100% up and running then? This setup? Anybody else? So what does this SLA say? Why it is this maximum uptime? Why it is not 100% uptime? See, this is actually a new thing, so you should think about it. it never says I will provide you 100% uptime, right? It says 99.95% uptime. It means no matter how many machines you put in an availability set, the maximum guaranteed uptime is 99.95% time. 0.05%. Okay. 0.05% of the time, it still might happen that both machines are down. So 100% uptime is not guaranteed. It is not legally, or you cannot sue or you cannot ask for damages from Azure or AWS or other service providers if they are meeting their SLA, and the SLA is service level agreement. So if their SLA says 99.95% of uptime, then, and with minimum two machines in an availability set, then that is the case. So you put two machines, you get 99.95% uptime. Okay. So the question could be, sir, then what if I put three machines for each role, right? Sure, you can do that. It will hopefully increase more uptime. It will practically, it could be 99.99% or 9.999% uptime. It could be, right? It will reduce because your machines availability will be increased. But SLA still will hold of 99.95% only. It will not increase. Adding more machines will not increase. So by design, the design you have for your setup, or the principle is same role machines in one availability set. Same role machines in single availability set. That is the principle. Now, how many machines you want to put should not be at least two, but whether 2, 4, 3, 6, 10, that decision should not be for making your machine service up and running. It should more be for based on the load that you're receiving as your requests come, right? Obviously, if I am setting up a website with two servers in one availability set just to make it up and running, which I also want, right? Doesn't mean that Amazon or Flipkart are also running in availability set with two machines, right? They might have hundreds of machines in a single availability set because they need such a capability to ingest the requests in coming through the web servers, right? So that decision, how many more than two in one availability set, should be mostly be based on the capacity building, the load, not on the availability per se. Because even if I put two machines or 100 machines, the SLA remains 99.95%. Practically, it will increase definitely. So it could be an aspect that we should put more machines availability, but you cannot blame Azure or AWS if still your service is down. Okay. And one more thing you should know is 99.95% looks a very, very high figure of availability. It is, of course. But if you, let's say, 1,000 minutes, okay, and okay, 100 minutes. 100 minutes may you have 99 point, my math is poor. So let 1,000 minutes may we will have, let's say, 5 minutes of downtime, because 99.95 means 5 minutes, right? 5 minutes in 10,000 minutes or 1,000. I think anybody can help me. 10,000 minutes may 5 minutes will be 0.05%. So 5 minutes is 5 minutes downtime is 0.05 of how much? That is the question. So let's say it is 10,000 minutes. So Amazon or a Flipkart service running on website, even even in 10,000 minutes, can it afford to go down for 5 minutes? Right? It's not desired, right? Bank website. In 10,000 minutes, can it go afford to go down for 5 minutes? No, you won't expect it, right? Airline booking or some live tracking or such applications, they are expected to run 100% of the time, right? So even though 99.95% looks high availability, it may not be true. So you should be um, aware of this, right? Zero point zero 0.05 could actually be some 100 minutes over a year. So in a whole year, 100 minutes downtime is quite a large amount of time, right? So it should be planned for. Adding more machines could be one reason. Some other way of doing things should be other reason. What I wanted to bring you to the understanding is that we need to think more maturely in cloud computing. It's not trivial. It is not easy or straightforward. We have got SLAs in place, we have got ideas and concepts in place which work theoretically, but we have got these practical aspects also, right? So cost is also cost, SLAs, availability time, uptime calculations, and all. These are generally not the domain which we as students learn things, right? We just learn the theory part of it, or we, even if the practical is being done, we don't get to those kind of details. Like even if I give you a practical, you may not be able to figure out that 5% is a really hurting downtime, right? Because we are not going to set up such system and test it out by being tested out by thousands of users, and then they start complaining if the service is down for 5 minutes in 10,000 hours, right? But for practical purpose, for an enterprise, for a bank system, for an airline system, that could be a business loss. So we we need to alter our thinking. It's very important. In addition to learning the skills of programming, being able to program uh, against the cloud, API and all, knowing about them, we need to orient our thinking that what is the implication of our action. Like the implication of our action. If you go to your company and set up the first way of doing things, like you set availability set like this, two availability tests, three machines, different roles, right? Seems to work fine, right? It will say one is up and running, but that is somebody else has done. You go and you redesign it like this, show it in the presentation to your team that our existing setup has is not optimal design. This is the optimal design, right? So it will make an impact, right? So concepts are important. We should learn any other subject concept, but in cloud computing, some, what I would say, business oriented thinking should also come. Return on investment should also come. That means cost. That means knowing about SLA, right? So these things should also be kept in mind. So whenever you are doing some exercise, whenever you are creating a virtual machine, whenever you are doing some resource creation in any cloud, think about SLA, think about the cost, think about the return on investment, think about if you are to pay from your pocket, what would you do? Okay, these things will help you, and I am talking from my experience. These things do not are not in any tutorial or anything. That these things will help you by combining the skills that you want to do for creating resources and all with these SLA knowledge, ROI knowledge, cost factor, incorporating cost factor in your work will help you eventually. Okay, so keep one of the goals that you should have in your mind about learning from this course is uh, take your thinking into second dimension of SLA, cost, availability, return on investments, business impact. Those aspects also you should start thinking about. In addition to the regular learning, like we do, let's say data structure learning and database learning and all, these things should also be there because they are the first grade um citizens. What happens is, in let's say database, for example, right? Database also will cost money. You will have to buy licenses, we will have to set up the machines and stuff. But this has been a traditional knowledge. When you go in a company, people will be already there who know all this out. Their IT folks know what machines will cost, what server license will cost, things like that. Cloud is new. Those old IT folks over there may not be knowing it, right? Virtual machines can be created just by a single developer a junior developer in a large team also. A junior developer in a large team cannot set up a database with a machine for a team, isn't it? So the dynamics have changed. First, there is a lack of knowledge in the older, more experienced people. Second, the ease of doing things has become much more prevalent. So you need to be aware of these things because you might be to end up doing these things on your own in the company, in the career path that you will take. You might be doing it on your own without necessarily somebody senior looking up for you that and correcting you. Okay, so this is a more responsibility that has come to junior levels when we start our careers because of this cloud. It's a indirect result, okay, side effect of cloud computing to that will become that is going to affect your career. Now, how does it affect? Does it affect negatively, or it you take this opportunity as a way to grow in your career? Is up to you, and that will come with this second dimension that I'm talking about. Keeping in mind the SLA, keeping in mind the cost, keeping in mind the return on investment, keeping in mind the answer to question: what if I were to pay for this resource from my pocket? Will I create it? Will I create it like this? What is the availability of this? How much uptime it will give me to increase my return on investment? Those level of thinking you should also do. Okay. And the difference between these two solutions is that thinking only, because both look okay, right? This also, the first solution also increases uptime as compared to single availability set, but most optimal is this solution. Okay. So I hope you understood and found it interesting. If you have any doubts, please let me know. Otherwise, we'll move to the next step.
Hello,
Anyone?
sir.
Yes.
Sir, if there are three machines in the same availability set, then is it possible that two are down and one is up at the same time?
Yes, yes, absolutely. Because think of availability set as a single machine, and inside of that machine, a single machine from the functionality perspective. Somebody looking at AV, it is looking as if it is a single machine, but inside of that means there are three machines, and logically, okay, and any of the three machines are if they are up, whole AV set is up, right? So um, you can think of it like something like a there is a glass like a some semi-transparent glass or something, and we have got three uh, LED lights or something like this. Okay, so the person who is looking at from outside, this guy, he or she cannot figure out that which light is glowing. Okay, this guy cannot figure out that which light is glowing. That person is just looking on this glass. Okay, any of the three lights glowing will make the glass lit. So from person's perspective, it is still lit, right? So that is the logically how availability set works. So availability set makes its functionality available by making sure at least one of the lights is lit, by at least one of the machine is up. Now you put two lights or four lights or three lights, doesn't matter. At least two lights should be there. Then 99.95% of the time, it will be up. But it could be possible if you have three machines, definitely it is possible that two of them are down. That is why this model works, right? Even if two of them are down, you still have third machine which plays the same role. It is still able to accept all the requests that are coming. So it will still make your service still up, isn't it?
Yes,
Did
sir.
you?
Got it.
Okay.
Yeah.
Anyone else? Okay. So what we should try is we should try this setup in our lab tomorrow. Okay. But actually, you can do it through the web interface. No need to run commands and all. Um, but we should try it out. This assignment I have not given it earlier to students because these infrastructure issues, being able to create so many VMs and all. But what you should try is mm, probably form a group or something, right? One or two groups, which can then you can try all together, because everyone trying to do the same thing might be costly. It will consume the credit quickly, right? Or some other way. The problem is cost actually. Uh, I will think about it how I can help, or at least I will try to give you demo or something in tomorrow's lab. Otherwise, I'll just put an assignment or lab plus assignment. As I said, lab and assignment basically same thing for this setup to be done. Okay, and there will be more details. For example, this is an infrastructure as a service setup, right? You are creating virtual machines. Um, we don't need to actually deploy web servers and all. We just need to make sure that we have availability set. We know how to create availability set, how to put two machines in one availability set. Um, it will be great if we can actually deploy it in a way we are thinking about it, but it will take a lot of effort and lot more time and detail to set up databases and all. Um, but at least we should, that goal is at least to set up these VMs and all in three different availability sets. Okay. Um, mm, and to cut short or to make it easier, what we can pick is once we set up these three, we can delete this one and we can use only these two for further exploration, that we can actually deploy a web server, and then some request comes through some tool, we can send the request that will come to S1 or S2, and then it will go to B1 and B2. B2 will simply return the request or some processing or something like um, reversing the string. You can put any algorithm in your B1 and B2. It will simply execute that on the data that came in and return the result. Then you can physically bring S2 down by turning it off from web console, or B2 down, right? That is hardware failures you can think of, right? AV set will have no control over that because we own the machines and I decide when S1 and S2 are up and running, right? But you will see that the request is still able to go and come back because the other machine is up and running. That will simulate it. Okay, but for that we will need to set up the S1 and S2 to take up both requests. So for that, the detail is that there is something called load balancers that will be required. So load balancers actually have one to many mapping. So it will receive a request from the left side and send it to any machine that is available on the other side. It will keep pinging them to know that they are up and running. So these load balancers are uh, additional thing that you might be able to confront or manage in the this I am talking about, the assignment I am talking about. Right. So that is why I was saying first goal is to set this up only with the same role machines in 3 AV sets, and how choosing, then we can say load balancer we can attach, and it will not only be here, the load balancers will be here also, right? Because that is how it is going to be able to send to either of the two machines. So we'll try to do this in our course, but if not done, that is, don't worry about it. I think it is important to know, but most of the time we will not be able, we won't be probably be doing this in practical things, because mostly now people have moved from IAS to PAS, but knowing about this still is very, very valuable. Okay, so unfortunately, you might be thinking this is not like definitive yes and no, okay, what to do in the assignment, but unfortunately, that is the case. You can take this to any level by setting up further and further security, network boundaries, things like that. So it is up to you how much deeper you want to configure or you want to explore. Remember, I talked about the career option available for IT people, which to those people who for whom programming does not come naturally, it is not a handicap. You just are not wired that way. So you can use this opportunity to dig deeper into this setup and actually install everything, web server, these S1, S2, B1, B2, D1, D2, set up a synchronized database between D1, D2, connect them through load balancers, expose the port for this service, write a hello world application which simply takes a request on one API call and sends this to B1, B2. B1, B2 processes it like I was saying, reversing the string or making it in caps or finding some other thing, stores it in the database and returns back the response. That can be done. So the IT people should try to do that actually, or one IT guy interested and one programmer guy. So these you two can combine as a team. The IT guy can try to set this up. The programmer folk can actually program it the way in the meanwhile, and then deployment onto these servers. So you are writing the code in a editor, right? Visual Studio or something, but you need to deploy it on this machine so that it is up and running. So that is also an experience in itself. That's a DevOps thing. So a lot of details, but to start with, three AV sets and three VMs in each of that, connected by probably by load balancers. That is the first thing I think we should try to do. Okay. All right. I think we had good talk on this. I hope things are makes that talk makes things interesting. Um, let's move forward, I guess. Oh, I think our time, quarter to 10 is our time. Lecture time, is it? Quarter to 10. Yeah. Okay, then we'll cover it in the next lecture. It took a lot of time. Anything else, guys? See, I have like 200 students registered for this course, and I have less than 100, and people are already leaving. Um, I would like better attendance. As I said, attending lecture will help you because you can ask questions. Listening to recording, those who are listening to recording after this lecture is over, I will request you to join the lectures. It is always better to learn it, discuss it live when it is happening, right? Use this opportunity to increase your knowledge in a skill set or about a skill set which is highly in demand, and it requires your effort. I am putting my effort, but it takes two to tango, right? So you also put your effort from your side, ask questions, do more than what I say, do more learnings in or through online, through tutorials, courses. Then only it is going to help. It's like mathematics, less of concepts, more of practical practice and knowledge. So we have less than 50% attendance in our course. Let's see if we can improve on that. Okay. All right. Take care then. Bye bye.
Sir,
Yes.
sir, can you share the recordings, sir?
I am sharing every day. I have uploaded them in the OneDrive, and you should be able to see that in the link in the Google group. I have not put the link, isn't it? See, here it is.
Acha. Yes, sir.
And
Thank you.
Yeah, somebody suggested me uh, for the YouTube channel, so I will do that if you can join. I don't know how it will be more advantages, but I will create a YouTube channel. I already have one for my startup thingy. You can join that, and I will upload these videos there also. Okay. All right. Thank you. Bye bye.